Hi guys, welcome back to another video of Solidity Basics, and in this video we'll discuss the payable keyword. So functions and addresses which are declared as payable can receive ether into the contract. Remember, whenever you are dealing with payable addresses, uh, write your logic in such a way that you're typecasting the addresses in a right way, because if it's a payable address, you have to store it in a payable address variable, or let's say you are storing some address which is not payable in a payable address variable. You'll have to typecast it using the payable keyword. So we'll go through the code we have here. We can declare any address as payable by adding a payable keyword in front of the address keyword. And if the constructor is supposed to receive some kind of ether during deployment, we can declare that payable as well. Because if you look at the first principles, constructors are nothing but functions that are invoked at contract creations, so we can make them payable as well. Then we are creating a deposit function which is also payable. We can send ether to this function and it would get added to a smart contract, or we can move it forward or do something else with it. We have a non-payable function where we haven't added the payable keyword, so we cannot send ether on this function. We'll get an error. Then we have a withdraw function where we take all of the balance of a smart contract. So this keyword points to the current instance of the smart contract, and address this dot balance fetches the balance of the current contract for us. So we get that in our amount variable, and then we send all of the ether of this contract to the owner of the contract. We also have a transfer function which takes in a payable address and the amount and transfers the amount from this contract to that address. Note that we take in a payable address because we are sending ether to that address as well, so it should be payable as well. We'll discuss more on the call keyword and how to use it in one of our future videos. So let's see how this code works out on the Remix ID. So we have the code here. We'll compile the contract and we'll deploy it. You'll notice that since we have a payable constructor, the button is red here. Up until now, it used to be orange in color. So whenever you are dealing with payable functions or payable variables, you'll see the Remix ID button as red in color. Just keep that in mind, because that is very useful in dealing with large code bases, or when you are just playing around with some sample contract. Payable functions and payable variables are to be handled with care, because you you are basically transferring values from here and there, and you don't want to mess things up and transfer it to the wrong place. So we'll deploy the contract. We'll pass in some value, let's say 1 ether with this, and we have our contract deployed. So first we'll try out the deposit function. The deposit function is payable, so we can send some value. Uh, so we can send some value with the function call, and that we can set here. So we'll send in 1 ether more. We'll deposit that, and you see the balance of contract going from 1 to 2 ETH. Non-payable function, if we try to add any value and call it, nothing happens. In fact, an error occurred and the transaction was reverted. Then if we want to withdraw all of the amount of this contract to the owner of the contract, which is basically this account, we can do that. In fact, we can call it from another account. We'll call it from the second account and we'll do the withdraw. The balance was 0 ETH, and our first account got its original balance. Initially, it was 97 something because we sent 1 ETH during deployment and 1 ETH with the deposit function. So we are back to 99 Ether. So again, we'll add some amount to the contract. let's say we'll add 3 ether to the contract. Now we have the balance 3 ether. We can transfer it to any account. So let's transfer some money to the second account. We'll transfer, let's say, somewhere around this much. This should be somewhere between 2 GUI and 2 ETH. And our second account currently has 99 ether. So let's see how this value changes when we call the transfer function. So our transaction was successful and the balance was reduced by some value. Let's do another transfer to increase the value. Again, you'll see that the value was reduced by 0.02 ether or something. So ideally we should see an increase in the value here, and you see that the value stored in this account address became 100.02 ether. So that is also working well. So that's all for this video. I'll see you guys in the next video.